Hello everyone and welcome to Keeping Tabs on Chemistry. In this video we are going to be discussing pH and the pH scale. So the pH scale was invented by a chemist named Soren Sorensen. It's a fun name. And pH measures the acidity of a solution as a function of the concentration of H+. So this makes pH a very useful combination of concentration and strength. Now we know that concentration and strength are independent of each other. Now concentration is based on the molarity, right? How much total do we have? And strength is based on the identity of our acid or our base, how much it dissociates. So the overall concentration of H plus is going to depend on concentration, total amount, and how much it has dissociated, right? The stronger you are, the more you've dissociated, so the more H plus, and the more concentrated you are, the more total amount, so the more H plus you have, right? So the pH scale runs from 0 to 14. Each step represents a factor of 10, and we're going to talk about why that is coming up. So looking at our pH scale 0 to 14, we've learned before that acids have a pH less than 7, so between 0 and 7. Bases are greater than 7, so they are between 7 and 14. Now, the actual pH 7 is neutral, right? That's our pure water. So if I were to look at a pH of 5 versus a pH of 6, that is one step, which means that pH 5 is 10 times more acidic than pH 6. Now if I looked at pH 3 versus pH 5, right, that is two steps. Right? So 10 times 10 means that pH 3 is 100 times more acidic than pH 5. Now on the other side, if I had pH 8 versus pH 13, that is 1, 2, 3, 4, 5 steps, so 10 to the 5th means that is 100,000 times different on the pH scale. So this is a way to visually think about pH and what it means that each step is 10 times different. So we're going to use circles and radii to talk about this. So starting with pH 6. pH 6 is going to have a radius of 0.1128. It's that little dot right there. Now pH 5 is going to be 10 times bigger than that. So its radius is about 1.1 centimeters. pH 4 will be 10 times bigger than that. 3 will be 10 times bigger than that. pH 2 will be 10 times bigger than that. And then the grand poobah here, pH 1, right, is 10 times bigger than pH 2. So from pH 6 to pH 1, that's a difference of 1, 2, 3, 4, 5 steps. That's 100,000 times bigger than that literal pH 6 dot. Okay, so thinking about pH of some common substances. Now, I've told you it's a combination of strength and concentration. So these are all based on 1 molar solution. So you can see a couple are on here. Your blood is slightly basic. The coffee you drink is, slightly acidic. So at pH 7, we have pure water, right? That neutral amount. Down at 2.2, we have lemon juice. That's sour, pucker your face, citric acid. Ammonia is on the other end, basic at 11. Drinking water is 7.2. Now, when you think about it, drinking water is going to be slightly basic because there are some detergents that we put into your water at water treatment plants that keeps it clean as it goes through our pipes and comes out the tap and things like that. So your drinking water is slightly basic for health reasons. Bleach is at 12, vinegar at 2.8, tomatoes at 4.2. Detergents and bile. Bile's in your digestive system, helps break down foods just like your stomach acid, hydrochloric acid, HCl. Then at the 0 is marked by 1 molar HCl. That is 1 molar of a strong acid. On the other side, 14 is marked with 1 molar of NaOH, right, a strong base. Okay, so acidic, basic, and neutral. The pH scale was constructed so that neutral is where your concentration of H plus is equal to your concentration of OH minus. That's pH 7. So if you think about it, here in this diagram, I've got 1, 2, 3, 4, 5 OHs, 1, 2, 3, 4, 5 H pluses. Everything is equal, it is neutral. Now in acidic, I'm going to have more H pluses than I have OH minuses. This causes pH to be less than 7. So in this diagram, I can see I've got 3 OHs versus 1, 2, 3, 4, 5, 6, 7 H pluses. Basic is the opposite. It's going to have more OHs, which means its pH is greater than 7. So here I've got 3 H pluses and 7 OH minuses. Now you might be wondering, Ms. D, how does that work? How does having more H plus mean less than 7 and less H plus mean more than 7? Right? That goes into how we calculate pH. Calculating pH from the concentration of H plus is a negative log function. Right? That is why each step is base 10 times different. It's because the log we're using here is log base 10, right? So every step is going to be a times 10. So here's an example of how we calculate pH. It says, what is the pH of a 4.3 times 10 to the negative 2 molar HCl solution? So looking at this, this is a strong acid, right? So I know all of this H plus is going to come off and it's going to split into H plus and Cl minus. So I can say that this concentration of acid is the same as my concentration of H plus. It has dissociated completely. We're not going to talk about calculating the pH of weak acids. We're only going to focus on strong. So I'm going to take the negative log of this value, right? Negative log of the H plus. So negative log of 4.3 times 10 to the negative second. So you might be going, oh goodness, how do I put that into a calculator? Well, on your calculator, there's a dedicated log button, or if not, it might be a secondary button. It might even be in a catalog, depends on the calculator you have. But on a standard TI-84, log is right there to the left of 7. So you get negative log, and then you have to input scientific notation in the parentheses. Now, there's a bunch of different ways you can do that. Some of you guys like putting in 4.3 times 10, and then you do the little caret negative 2, and that's fine because this is going to be contained in parentheses. I prefer to use the EE function, which is just quicker. So you do 4.3, and then the EE is second, and then that comma, you see that EE. That cuts out the times 10 and the caret. So you do 4.3, the EE, and then just the negative 2. Whichever way you do it, you end up getting 1.4 out of your calculator. Some of you might be worried about sig figs. Don't worry about it. We're going to say 1 decimal place is good enough for this class. So now that you know how to calculate pH, you can actually go the other way. So you can find the amount of H plus from the pH. Now the opposite function of log is 10 to the exponent. So the concentration of H plus is going to be 10 to the negative pH, right? That negative is carryover from the fact that it was negative log, so now it's 10 to the negative pH. So what is the concentration of H plus in an HCl solution with a pH of 2? Okay. So I've got my acid, I know its pH, I want to find the H plus. So I'm going to do 10 to the negative pH, that's 10 to the negative 2, which if we expand that out, it's 0.010 molar. Okay, so at this point we're going to break and give you a chance to do practice number 3. If you'd like to pause the video, when you're done, go ahead and unpause the video and we will go over the answers. Okay, hopefully you guys have had a chance to try out practice number 3. So in number 1, it says, what is the pH of an 8.7 times 10 to the negative third molar HBr solution? So HBr is an acid, it's a strong acid, so I know that pH is going to be the negative log of that H plus, right? It's the same concentration as the acid. So negative log of 8.7 times 10 to the negative third gives me 2.1. Right? That makes a lot of sense. It's an acid, so its pH should be less than 7, and it is. In question 2, it says, what is the concentration of H plus in an HNO3 solution, that's nitric acid, with a pH of 4.6? So here I'm going to do 10 to the negative pH to find that H plus. So 10 to the negative 4.6 gives me 2.5 times 10 to the negative fifth molar. Alright, now pH is not the only function that we can use to look at acidity or alkalinity. We can also use pOH. Right? So where pH measures the concentration of H+, pOH measures the concentration of hydroxide ions in the solution. So here you can see the pH and the pOH scale kind of side by side. Now on the bottom, the pH that we saw before, 0 is acidic, 14 in basic. You might notice that pOH actually goes in the opposite direction. 14 is acidic, while 0 is basic. So as pH is increasing left to right, pOH is actually decreasing, right? And vice versa. So as pH decreases, pOH increases. So at low pH, we have a very acidic solution, but at low pOH, we have a very basic solution. So you can see how this would kind of get confusing. You're going to want to, if you're trying to identify acid and base by these values, you're going to want to use pH, right? Low pH, acidic, high pH, basic. If you try to switch between pH and pOH, it's very easy to get confused because they're opposites of each other. So it's much easier for say, all right, we'll just use pH to say, determine if it's acidic, basic, or neutral. So calculating pOH is just like you calculated pH. The pOH is going to be the negative log of now the hydroxide instead of that H plus or hydronium. So in the example, it says, what is the pOH of a 2.5 times 10 to the negative fifth molar NaOH solution? Now, NaOH is a base. It produces OH when it dissociates, and it's a strong base, so it dissociates completely. So I can say that that concentration of NaOH is my concentration of OH minus. So I'll take the negative log of that, and my calculator will give me 4.6. Now, going the opposite way, the opposite of log again is 10 to the negative exponent. So for my concentration of OH, if I want to find from the pOH, I take 10 to the negative pOH. So what is the concentration of OH minus of an NaOH solution with a pOH of 5.4? So 10 to the negative 5.4 gives me 4.0 times 10 to the negative 6 molar. Alright, so now we have practice number 4. Go ahead and pause your video and you're ready, unpause. Alright, looking at number 1, it says, what is the pOH of a 4.3 times 10 to the negative 6 molar KOH solution? To find pOH, we take the negative log of concentration. So the negative log of that 4.3 times 10 to the negative 6 gives me 5.4. In number 2, what is the concentration of OH minus in an LiOH solution with a pOH of 6.8? To find concentration, I do 10 to the negative exponent. So 10 to the negative 6.8 is 1.6 times 10 to the negative 7th molar. And don't forget your units there. Alright, our final section of this video, we're going to talk about how you convert between pH, concentration of H plus, pOH, and OH minus together. So the relationship between pH and pOH, you can pick any point on the pH/pOH scale, and you can add up the two values. So on the very left-hand side, I got 14 plus 0 is 14. 11 plus 3 is 14. 9 plus 5 is 14. 7 plus 7 is 14. 6 plus 8 is 14. 2 plus 12 is 14. And it's not just whole numbers that do this. Any point on this scale, pH plus pOH is going to equal 14. So this lets us go between pH and pOH using this equation. So what is the pOH of a solution with a pH of 3.5? Well, if pH plus pOH is 14, I can rearrange this equation to solve for pOH. I can subtract pH from both sides. So pOH equals 14 minus pH. So 14 minus that 3.5 means my pOH is 10.5. Now this lets us convert between all four of these quantities. If I know one, I can get to the other three. So we're going to make a flow chart or a diagram to help us through this. Now starting in the upper right hand corner with this concentration of hydronium, to calculate pH, I can take the negative log of that concentration. Then if I want to calculate pOH from pH, it's 14 minus the pH. To calculate concentration of OH minus from pOH, it's 10 to the negative exponent. Now that's one direction here. We can go in the reverse direction as well. So calculating pOH from the concentration of OH minus is negative log. pH from POH is 14 minus POH, and then the concentration of calculating pH from POH is 14 minus the POH, and then to calculate the H plus concentration from the pH is 10 to the negative exponent. So now from anywhere here, I can calculate all three of the values. So let's look at some examples. What is the pH of a 1.6 times 10 to the negative second molar NaOH solution? Now, your first instinct might be, oh, I want pH, I'll just take the negative log of that concentration. You can't do that though, because this is not an acid. NaOH is a base, and I'm asking about pH, not POH. So I first need to get this to POH to calculate pH. So I'm going from the bottom right here up, over and up. So my first calculation here is going to be POH equals the negative log the concentration of OH minus. So I got the negative log of that concentration. My POH is 1.8. To find pH from POH, I'm going to subtract that POH from 14. So 14 minus 1.8 means my final answer is 12.2. Another example, what is the concentration of OH minus ions in a 2.9 times 10 to the negative fourth molar HCl solution? So it wants concentration of OH minus, but I've given you a concentration of an acid of H plus. So this is going to be going through 3 steps. So we're going to start by going from H plus to pH through negative log. So the negative log of my acid concentration gives me a pH of 3.5. Now to get POH, I'm going to subtract that from 14. So 14 minus 3.5 is 10.5. Finally, to get the concentration of OH minus, I'm going to do 10 to the negative exponent. So 10 to the negative 10.5 means my concentration of OH minus is 3.2 times 10 to the negative 11th molar. Alright, go ahead and pause the video for practice number 5 and unpause when you're ready to see the solution. Okay, what is the pOH of an 8.5 times 10 to the negative third molar HNO3 solution? So I want pOH and I'm given acid concentration. So I'm starting in the upper right hand corner. I've got 2 steps to get to pOH. So I'm going to start by calculating pH as the negative log of that concentration. So negative log of 8.5 times 10 to the negative third gives me 2.1. To find pOH, I subtract that from 14. 14 minus 2.1 means my final answer is 11.9. Alright, well that concludes my video on pH and the pH scale. I'll see you next time.